Hey guys, this is really turning into my favorite project of all time. This is the new powerbank. I got a comment on my previous video on the previous revision of the powerbank that it was kind of silly. Here, I'll show you. On the previous powerbank, I had these battery pads to connect to the battery, and I had to like weld the battery tabs and then have the little wires hanging off of it. And took up a lot of space and wasn't quite well. In retrospect, it didn't make that much sense compared to the new solution, which is to quite obviously just have these battery tabs run all the way into a plated slot on the PCB. So yeah, kind of an obvious solution. Not just that, the biggest difference with this power bank, and the one that I'm just ecstatic about, is I added a microcontroller. And you would say, well, why do you need a microcontroller in a power bank? Well, I added measurements to it. I don't know how useful this is to like general power bank users, but I just really like it. The idea is that I can measure the output current on the USB, output current on the higher voltage output. I'll get into that. Measure the charging current, measure the battery voltage, and obviously also a microcontroller control these LEDs. And I added programmable voltage setting for this port. So you can now vary it from about 9.5 to about 24 volts output. It's constant power, so your output current capability does go down as you increase the voltage, but then on the other hand, the output current increases at a lower voltage. So at 9.5 volts, you can output almost 4 amps, which is kind of cool. It also has higher efficiency at that point. So yeah, overall, this is just an improvement. There is, on this board, doesn't quite fit in the enclosure yet because I've got these two break-off tabs. This is the temperature sensor, which I have to break off and put somewhere in the pack. And this is the programming port for the microcontroller, which I'm gonna leave on until I know for sure that all the firmware is all right. All right, so here is the interface for the power bank, and it is just, I'm so happy with this. Let me just turn on the power bank. And we can see a couple of interesting things. So first of all, this is this blue line that's on top. That's the HV output voltage. It's at roughly 12 volts. Should be pretty much exactly. I can tweak it here. I can tweak it up and down. I'll just show you. Goes all the way up to 24.8 volts, almost 25 volts. And it goes all the way down to about 9.5 volts. Also, you can see that the step size is not the same across the entire range. At the top, the steps are like almost, they're more than half a volt, I think. And at the bottom, yeah, here we go. This is the minimum, 9.55 volts roughly. At the bottom, the step sizes are very small. That's just the way I'm using a digital potentiometer to set the voltage. So this is just how that goes. I can see the battery voltage here. That's the like the light teal, almost white line at 4.198 volts right now. And then here on the bottom, there are the different currents. So the charging current, currently 0. And USB current, currently negative 41 milliamps. So the USB and HV output current, so the two actual output ports, they are not super accurate. I'm using the microcontroller itself to measure these with some internal gain. And there is, you will see this soon as I plug in stuff to charge. It's not ideal, but this power bank is not meant to be a high precision measurement instrument. It's just, this is basically just an indication of what's happening. And it's a pretty darn cool indication, if you ask me. Basically why I built it. So, well, let me just show you let's just plug in my phone, for instance, into a USB port. And there we can see the phone starting to charge. So this green line is the USB current, and it's currently at about 550-ish milliamps. And here you can see what's going on. I will just change the time base. As I start drawing current from USB, it almost seems like the high voltage output is also outputting current, but it's not. This is just crosstalk between the ADC channels. Yeah, I'm going to fix most of this. It's pretty bad right now because there's basically no good front end on the current inputs, and the same goes for this. The high voltage output seems to be a bit lower. It is actually slightly lower. I think there is a little bit of internal resistance going on that has a multiplier effect on the output voltage. Not 100% sure, but yeah, the ADCs are not great, but it's awesome as an indication of what's going on. Especially on longer timescales, you can really see the current going down in like an E-curve type situation. Well, other things you can do, so I showed you that you can change the voltage. I can change the name, so let's just go for something yeah. This name here that I chose, it's actually in EEPROM. So your power bank will retain this name. If you go to another computer and start up this interface, it will show this name. So here you can just see, well, let's say my name is Eric. And then you know for sure that if you're modifying settings on this, that you have your own power bank. Maybe you have multiple power banks because obviously you really like me and you want to buy many power banks from me. So Max is 21st power bank, and I am, yeah, it is limited to 16 characters. So sorry about that. I will look into extending that because there's a lot of EEPROM space. So maybe I can make it 32 or something. Yeah. Some other things you can do. I showed you that you can change the time base. So now we're looking at 10 minutes worth of data. Yeah, there we go. We only have about 10 minutes. So here you can see that we were messing with the voltage output. And here I plugged in the phone, and it started charging at a high point, but then kind of slowed down. It's almost full, clearly. Other things you can do. Here, that charger chip that I use, the BQ24295, it has lots of internal settings. You can set the input under voltage threshold. So that's as it pulls current from the USB line, the voltage kind of sags because of line resistance and that kind of stuff. So you can actually say, well, keep drawing current until the input voltage is only 3.88 volts, and you can change that up to 5.08 volts. So that kind of protects your charger, so to say, or your cables. Then there's the input current limit, currently at 3 amps. You can set it all the way down to 0.1 amp. Yeah, so let's put it at 0.15 amps so I can show you some stuff. Charge current limit, again, can go all the way up to 3 amps, 3.08 amps. Very fine-grained control here. Pre-charge and termination. So pre-charge is when your battery is really low. You can set the current at which it charges up to a certain point, about 3 volts. And after that, it goes into fast charge mode. And this charging current limit is what you use. Then there is termination cutoff. So if the current falls below 0.128 amps, and termination is turned on, so you can do that here with this, then it stops charging. Then, well, battery charge voltage. This is something that I don't think will make it in the final version, because you can set this up to 4.4 volts, and that will definitely damage your NCR 18650Bs, like the 18650 batteries that I use. So yeah, not a good idea. But yeah, you can change it all the way from 3.5 to 4.4 volts. Well, then there's a charging timer. So this is a setting that you can use. You can use it in combination with a 2 times slower timer to make it so the power bank automatically stops charging after a certain point. This is a protection feature that if you have like a leaky battery that is constantly discharging, like self-discharging, that you don't keep charging it and keep feeding that problem for very long. So there's a charging timer that can go up to 20 hours, and then times 2 is 40 of this bit, or as low as 5 hours. By default it's on 12 hours. By default, by the way, it is on, but I turned it off, so you can completely disable this timer with this bit. Here, turn it on, turn it off. And well, then you can see here the status of the charger chip is it's not charging. The battery voltage is 4.17 volts, so it could take a little bit of charge. So let's just enable the charger, and we can, yep, there we go. We just reduce the time scale. Here we go, it's charging at 0.12 amps. That's kind of low. I can charge up to 3 amps. But remember, we put this input current limit at 0.15 amps. And we can increase that to 0.5, and then we see a jump. And 0.9, and another jump, and now it's definitely, I can increase this more. Let's see the charging current limit, maybe that has something. Yeah, that helps a bit. But yeah, I can now increase everything as much as I want to 1.5, 2 amps. But it's so close to being full that it won't actually accept more charge than this. But it can go up to 3 amps. By the way, currently the PCB is just designed not quite right for the full charge current. So if you charge at 3 amps, it will overheat, and you can actually set the thermal cutoff between 60 and 120 degrees for the chip. This is, yeah, I need to fix this by making better heat sinking on the board. So the board is going to have thicker copper, and we'll have more thermal vias, and we'll actually have a little thermal thingy that goes to the case, like a thermal pad, to make sure that it can lose all the heat, because it does produce like 2 watts of heat if you charge it full bore. This thing can get pretty warm, and I should do my thermal design better. Yeah, that's basically it. You can download images. Here we go. So this is a snapshot. This is a transparent PNG, so that's why it doesn't have like a background. And then, well, you can show the raw registers here. So these are all the registers in the charger chip. It's not very pretty. This is much easier to work with. So yeah, that's the new version of the power bank, and I'm super happy with it. There are still a bunch of small issues to figure out, so it's not going to be on sale right now, but I am definitely going to sell it. Possibly I'm going to try maybe a Kickstarter to get into the volume where this can be like $50, because currently at the costs I have to make this, it's definitely going more in the direction of $100. That's, most people are not willing to pay that much for a power bank, even like an advanced one like this. So yeah, I would like to have higher volume and get the price down a little bit more. We'll see. In the meantime, well, there are a couple of issues. For instance, yeah, there we go. So here you can see that LED is slightly on, and that is a design flaw. It is oriented in such a way that it's feeding a very tiny amount of current from the battery into the microcontroller, and the microcontroller is in brownout bounce mode currently. So it's very slightly draining the battery. Yeah, that's not good. There are a bunch of other small things. I still have to address some of the efficiency issues and the heat issues. I still have trouble delivering full output current at high voltages. There are just too many switching losses, so I have to experiment with these MOSFETs. Same goes for this MOSFET. Still getting slightly too hot, so I have to try out a bunch of different ones and see which one is best. I have had the stupidest mix-up ever. Switched out the D plus and D minus lines on the USB port. It's just, there's no reason that should have happened. And yeah, just small stuff. That really has to happen before a production revision. But otherwise, it's a cool product. I really like it. And I hope you liked it too. And I'll see you next time.